as Leah Henderson. I would just be curious to find out who you are.
I'm sorry, Dr. Beal. What's going on?
Oh, so you are Leah Henderson?
Yeah, I don't know why it's coming up as Leah Henderson. It should be Matt.
Weird. Okay.
Yeah, I don't know why it's doing that.
Yeah. Anyway, this is kind of weird. It says Leah Henderson joined the group. That evidently was you. I don't know why. You're not on a Leah Henderson computer, are you?
No, I'm on my own computer.
Okay. Well, whatever. It's good to have you. And welcome. Okay, we're live, so I'm going to get started here. You aren't seeing my picture today because, well, I had a student in here about 15 minutes ago, and we were going over some test items. So I decided I didn't want to take the risk of unsharing and sharing again, so screen sharing on. All right. Well, the lesson today, we're starting chapter 2, is linear equations in two variables. This just means good old straight line equations. One of the and this is, for the most part, review. It is incredibly important, though. So it's really worthy of close attention. Okay, now I have Matt Bishop and Leah Henderson. I'd still like to know who Leah Henderson is, but anyway.
Oh my, that's so weird.
Yeah. Anyway, all right, linear equations in two variables. So here's what we have. Here are the learning objectives. Big part of linear is, good old y equals mx plus b. That means we're going to be talking slope. We're going to be talking y-intercepts. How do we write their equations given 2 points or given 1 point and the slope? All these different kinds of problems you'll be thrown into. And then to make sure everybody remembers how to deal with parallel and perpendicular lines when it comes to slope. And then, of course, word problems. Now, at the bottom here, I just wanted to show you what they mean by linear equations in two variables. So in the box here, you see y equals 3x plus 9. That's a good old equation. And I was just showing you that there are two variables. That's where the book is that type of linear equations in two variables. So welcome, Brandon.
Hello.
How you doing?
I'm doing all right. How about yourself?
I'm glad to see those of you in the room here survive the campus event today. Doing fine. So, yeah, I was just explaining the title here, and this in the box we have an equation that's a linear equation, and it has two variables, x and y. That's why it's called linear equations in two variables. You can ignore the part on the right that was to apply something previous. So, the first big thing we want to talk about today is slope. A very important part of linear equations is they all have a slope. So what we have here is a slide that shows a generic 2 points, x1, y1, and x2, y2, and a reminder of how does one calculate slope. Different people have had different teachers and have taught this different. You might have been told, this amount going vertically here is, and the horizontal, sometimes they call run. So sometimes this is thought of as rise over run. Thought that way. That's correct. When it comes, what is the rise? It's the from this down to the height of the first point, y1, y2 minus y1, and then what's the run? Where the x2 is here, back over to the x1. So, I mean, way up at the top in the box looks familiar to all of you. So M is typically used to represent slope. So the here's another way you might have learned it. The change in y or change in x. Yeah, sometimes they write that like this, delta y over delta x. So I've probably hit just about all the ways that's taught in high school now. All right. That formula is really important. So let's practice. Given these 2 points, the slope of the point of the line that connects them. As you well know, if you have 2 points, there's only one line that can connect them. 2 points determine the line. You were taught probably in geometry class. So, by the way, it doesn't matter which you call point 2 and which you call point 1. I'm going to just do it this way. You could do it the other way. It doesn't really matter. I'll maybe demonstrate it. So if you find the slope, we want to do the y from point 2 minus the y from point 1 divided by the x from point 2 minus the x from point 1. So in this case, what is that? 2, 3, minus the y-coordinate from point 1, 2, over the x-coordinate from point 2, negative 5, minus the x-coordinate from point 1, so we get a slope of negative 1/6. Just checking to see if I did that right. So I'm assuming that's pretty straightforward. I went a step further here. What's the equation of the line? Well, now that we've calculated the slope over here, negative 1/6, all lines are going to be in this y equals mx plus b format. So now we literally plug in our m, which we just calculated. We need to find b, the y-intercept. How can I do that? We need to what? Substitute in either one of the 2 points from up above. So I picked the first point here, plugged in the 2 for y and the 1 for x. And then you do a little bit of math and you can solve for b. Once you know b, you can write the entire equation. So that's one of the activities that's very important today. Anybody need me to pause there? Are there any clarifications?
Yeah, one quick question. What if you did the points backwards, like the 1, 2 was...
How about if I'll do it over again? I'll tell you what. What I'll do is let's go back to this slide, and I'm going to just copy this page, and then on this page I'm going to just erase all of this, and we'll do it the other way. So this time, yeah, thanks, Brandon. I forgot I was going to do that. So let's call this point 2 and this point 1, which is the opposite of what we did the first time. So once again, the slope, y2 minus y1 over x2 minus x1. Now I got to get this keyboard out of here so I can write a little bit better. Okay, so in this case, now what's the y-coordinate from point 2? 2 minus the y-coordinate from point 1, 3, over the x-coordinate from point 2 minus the x-coordinate from point 2, from point 1, sorry. So on top, we get a -1. At the bottom, when you subtract the negative, you wind up adding. Okay, well, do you see how we got exactly the same slope we got going the other way? Here's when we did it the other way. We got -1/6. And by reversing it, made no difference. And it never will. Now, the only thing you can't do, Brandon and everybody else, you can't change your mind halfway through. You know, but just commit. You can call either 1.2, either 1.1. Just follow through with it. Stay with your numbering system, and yeah, you can't go wrong. All right, let's take a look at another one. So this one's leave here. Let's say we want to do the points 5, 2, and 3, 5. And you can see I decided to number them a little differently this time. It doesn't matter. By the way, I would recommend that you write on your paper which one you picked as point 2 and which one you picked as point 1. That way, when you look back, you'll know. Slope, the y-coordinate from point 2, 2, minus the y-coordinate from point 1, 5, over the x-coordinate from point 2, 5, minus the x-coordinate from point 1, 3. So we get -3 on the top, we get 2 on the bottom. There's my slope. And if we're going to keep going and find the whole equation, we know we want to requirements y equals mx plus b. So let's plug our slope in. We just calculated it to be -3/2. So we plug it in and then plug in a point. And this time I plugged in the 0.52, which was that one up on the left there. You gotta, it doesn't matter which one you use. Plugged in 2 for y, 5 for x. I'm not going to do the arithmetic here, but it comes out to be 9.5 or 19/2. Okay, well now you've got your y-intercept. So now the final m and b, you got it. You got the entire equation. Again, let me pause. Are there any questions?
Where'd you get the 5 from?
From the problem up above, the first point I picked.
Okay.
Whoop, that I didn't want to do. I thought I had my marker. The first point I picked was, so I got that 5 from right there.
Okay, you just used that for the x value.
Yeah, we could have taken 3 for x and 5 for y from, you know, the second point. Doesn't matter, either one. You have to, when it comes to plugging in down here, you have to pick a point that you know, and that would, in this case, was given to you. Maybe I should demonstrate. I'll tell you what. Let's do one thing to follow up on your question. Pete, we were right at this position. Let's plug in the other point. I'll just show you how it doesn't make any difference. What was the other point? 3, 5. Goes in for y. And this time we're plugging in 3 for x. Equals -9/2. Then we would add 9/2 to both sides. And this is what? This is 10/2 here. And when you add 9/2 to 10/2, you get 19/2. exactly what we got when we did it the other way. And so again, that will always work. Okay. Let's do another one. Let's find the equation of the line that contains these 2 points. Okay. Yes, is there a question out there? No? Okay. So Matt, I'm going to give you the choice this time. Which point should we call 1 and which should we call 2?
We'll call 2 the 35 and 29, and then the 1 the negative 4 and 5.
Thank you. That's what I'll do. Okay. So let's start by finding the slope. So the y from point 2, 29, minus the y from point 1, 5. Or the x from point 2, 35, minus the x from point 1, negative 4. Don't be careful of that sign. The students sometimes get a little sloppy with that. 10 minus 5 is 24. And 35 minus a negative 4 is 39. Maybe not real friendly, but there's my slope. So now we know we're headed for this. Y equals mx plus b. And we just found, well, let's plug that in. So, okay, we got to start on the line. And now let's plug in a point. And you probably would agree with me on this. When it comes to picking a point, you can pick either one of these two. Hey, pick the one with the smaller numbers. It'll make it a little bit easier on you.
Yeah, that's fine.
So this time I'm going to plug in 5 for y. And we're going to plug in negative 4 for x. Okay, so what do we get? 24 times 4 is what? 90. That's a negative 96. I got to continue over here on the right. So we're going to, what, add 96 39ths to both sides so that we can solve for b. So we've got 5 plus 96 39ths denominator. So 5 is what over 39? Well, it was 3 times 5 would be 200. So it must be 195. 195 39ths plus 96 39ths. And have a common denominator so we can bring those together. So if you add 96 to that, it's 100 minus 4, so it should be what? 291? Got it. So now just go back and rewrite the equation, leaving, m as we found it earlier. The b, we're going to be in our... Yeah, and I actually prefer that you leave those in the fraction form like that. If you can simplify the fraction, we should do that. But you know what? This one could be simplified, but for right now, that's good. Let me just check. I think I did this down below. Yep, got the same answer. Okay, cool. Okay, I'll pause. Any questions? There's a lot of this type of work on here. I mean, I know this is pretty high-level stuff, but it's very important. Okay, not hearing anything. Let's go on to another one. Now, I've been known to do problems of this type on quizzes, on tests. So I'll just give you, like here, I gave you 3 points, point A, point B, and then I'll do something like this. Find the equation of a line perpendicular to AB and including, that means going through, point C. Now, before we do that, who remembers? In algebra, what does it mean if two lines are perpendicular? Well, we know it, they make a 90-degree angle. But what do we know in algebra about those two lines? Their slopes are, I always taught it this way, their slopes are negative reciprocals of each other. So the one slope is flipped upside down and has the opposite sign. You guys recall that? Also, I'm going to ask you this question. What do you know from algebra about two lines that are parallel? They have the same slopes. So, yeah. So, those are very important. You see them highlighted in the textbook. So anyway, here we have a problem that involves perpendicular. Okay? So if I need something perpendicular to AB, and I know that perpendicular means negative reciprocal, then don't I need to find the slope of AB first? So step one, get this back here. Okay. Not getting any response here. I'm stuck on the eraser. Okay, let me try tweaking my batteries again. Hang on a second. All of a sudden, my pen is like not doing anything. Just a minute. My battery was pretty new, but I may need another one. Let's see if this does anything. Yeah, we're up and running. Okay, good. One is I need to find the slope of AB so that I can, so that I can capitalize on this part of the given that it's perpendicular. So we got to use our slope formula. M equals y2 minus y1 over x2 minus x1. So now you're doing A and B, so you gotta, here, let me get a different color. So should we call this point 1 and this one point 2? So y2 is 5, y1 is 1, x2 is negative 2, and x1 is positive 2. So if I did my arithmetic right, I get 4 over negative 4, so the slope of that line is negative 1. So let me just say, step 2. What is slope answer? I mean, our line is perpendicular to that one. What's the negative reciprocal of negative 1? Positive 1. Yeah. So now we've got our M. That's our M. Like before, we're going to start our mx plus b process. So we know we're aiming here. And we just found M. So y equals 1x plus b. Well, this is going to be nice and easy. Which coordinates do I use for substituting in? I was only given 1 point that our line went through, and that was point C. So do you see in this case, I have to use x is -4 and y is -3. Because of this direction right here, it's including c. All right, so let's plug that in. Y is -3, x is -4. Now I got some space here. So add 4 to both sides. Add 4 to -3, you get 1. So therefore, the equation of our answer must be, I mean, no, you really don't have to write this first one here. But we just found B is 1. So we have now completed the project. So follow that. So I gave you the specifications for finding the slope, and you had to follow the clue that it was perpendicular to side AB. So step 1 is I had to find the slope of AB and then flip it upside down and change the sign. Now we have M. Now go to clue 2. It goes through point C. So then you plug in point C. Hopefully that makes sense. So that's the kind of problem you're going to get one way, either in a quiz or a test, or maybe both. I don't know.
Hey, Dr. Bealo.
Yes.
I don't know if I just missed it, but why is the reciprocal the slope of the answer and not -1?
If the two slopes, if it was -1, then both lines would have the same slope, and lines that have the same slope are parallel. They certainly can't be perpendicular then.
Oh, okay.
So if they were
Yeah,
parallel, of course, they're never going to touch, and it doesn't make sense. Okay. All right, let's take another one. I'll practice one more of this type. Maybe we don't have time. Yeah, let's do one more. So here's another sample. Here I have the same 3 points we had before, but this time notice the directions are different. It says find the equation of the line parallel to BC and going through point A. Parallel, so it should be the same slope as BC. All right, so step 1, find slope of BC. So we know that it's what? M equals y2 minus y1 over x2 minus x1. Let's call this point 2 and this point 1. Okay, y2 is 5 minus y1 is -3. x2 is -2 minus x -4. Got all kinds of signs there. We get an 8 on top, and we get what? A 2 on the bottom, right? -2 plus a +4 is 2. Slope here appears to be 4. All right, now, good news. Our line is parallel to that, so our slope also has to be 4. So, as we're heading for y equals mx plus b, we know that m is a 4. Okay, whoa, I gotta go up too high here. Which point does it go through? Point A. So I gotta use these coordinates now for substituting in. So y is 1, x is 2. Now we should be able to solve for b. Why did I put an equal sign there? That was... There we go. Subtract 8 from both sides. We've got our y-intercept now. So let's just take a look. So we write it out with our slope, 4x minus 7. Oh, you can also say, if you want, plus a negative 7. Let me just check it. I did it a different, yep, same answer here. Questions on that one? Now, let's dig into some of the problems coming up on the assignment, okay? Yeah, if you look at, let me see, I got to get to the right page here. Yeah, I don't know. I don't know where I am, so let's take one I do know about. Let's take a look at number 92. Okay, number 92 says, write the slope-intercept form of the equations of the lines through the given point in part A, parallel to the given line, and in part B, perpendicular. Forgot to talk about one thing. What is the slope of a horizontal line? Let me insert a page here. Okay. I mean, in general, let's just talk a little bit about slopes. I always think of it this way. Positive slopes are what? Uphill from left to right. You know, if you just think of it this way, that's how we read from left to right, correct? So if you're going uphill as you move from left to right, that's a positive slope. If you're going downhill, that's a negative slope. If you're horizontal, that's a zero slope. So level is a slope of 0. Well, what do we do with a vertical line? Well, what's rise over run? Well, you got all kinds of rise and you have no run. So you got numbers like 7 over 0. I know, that's trash. You can't do that. So we call this, I mean, it's undefined. So in other words, you can't list a slope for a vertical line. Okay, so I just wanted to, I needed to get that in here. Now let's go back and talk about number 92. So here's, let's see, what's 92? We have the point 4, negative 2, y equals 1. Okay? Isn't that another way of saying y equals 0x plus 1? Right? There's no x, so that means that must be a term that's nothing. That's 0x. So in other words, what is this? Y equals 1 is a horizontal line that's 1 up. Y-intercept of 1. So, you know, it looks like this. You got your graph, and if this is 1, y equals 1 is a horizontal line parallel to the x-axis going through 1. So in part A, the question is, if we want a line parallel to that dotted line, what's its equation if it's through this point? Well, it's got to be horizontal, so it's got to be 0. It's got to be parallel to the same slope that we had here, right? So it's got to be 0. But it goes through the 0.4, -2. So doesn't it have to be 2 units below? You know, if the point is 4, -2, that would be 1, 2, 3, 4, -2. So it's like over here. And it's got to be parallel to that one above. Isn't it going to look kind of like that? That new line have to be at the height of the same height as that point. So, weird one, because we don't have any slope here. So it's y equals 0, x minus 2 this time, or just y equals -2. But now here's the weird one. What's a line perpendicular to this first blue line right up here? What's the equation of a line perpendicular to that dotted line that goes through the 0.4, -2? Well, can you see that it's going to look like this? It's got to be a vertical line, because otherwise we won't have a perpendicular. Oh, and what does a vertical line do? Have an undefined slope. They don't fit, but they always are of the type x equals 4. You know, they're x equals a constant. Another little lesson here. All horizontal lines are going to be in the form of y equals a constant. So horizontal lines are always going to have a slope of 0, and they're going to look like y equals, you know, some constant, which I'm just calling k. Oops. I have nothing logical to tell you there, but they're always going to be of the form x equals some other constant. I don't know, let's say a. So, and you see in this case, that's what happened when we needed a horizontal line here. We got y equals, no, again, a constant. And when we needed a line, vertical one, we had just x equals a constant. So that's the one thing that doesn't fit y equals mx plus b when you have a vertical line. So I picked that out for a reason. Make sure you... I don't know. Does anybody have a follow-up on that? So 92 is unique. Vertical and horizontal lines, and we hadn't talked about that yet today. How are we doing on time? 12:08. Okay. So let's take a look at a problem like number 84. So I'm backing up now. Previous page. And by the way, it says use intercept form. I do everything in terms of plus b. So any directions you see in the book that ask for a general form or a intercept form, just go with, for the whole lesson, y equals mx plus b. So here's the deal. In 84, they give you the x-intercept and the y-intercept. And the question is, can you find the equation? And we're going to go, instead of what they said, we're going to shoot for this form, as we're going to do with the entire lesson. Plus 2 points. Do you know how to find the equation of a line given 2 points? Yeah, start by finding the slope. Same old deal. So this is kind of a repeat. Slope. I numbered the points. You see that up here. I called that one. It doesn't matter, but that's the way I did it. So what's the slope? y2, -2, minus y1, 0, over x2, 0, minus x1, 2/3. Well, -2 minus 0 is -2. 0 minus 2/3 is -2/3. 2 divided by 2/3 is -2 times -3/2, right? You apply reciprocal. a negative is a positive. The 2's cancel, and you get 3. Yes? So now we know M. So y equals 3x plus b. Do I have to do any calculating to find the y-intercept? No. They gave it to us. It's right here. -2, so save yourself the trouble. Question? You know, it's spooky with it being quiet. I appreciate your respect, but classroom, at least I can look at eyeballs and reactions, and here I can't even do that. So at least not with me taking them, and everybody's got their pictures turned off. So let me just take a quick look here. Except for Brandon. Brandon, I see you staring. Did you have any questions, Brandon?
I don't think so. I think I understand it, but we're always going to be using y equals mx plus b even past this assignment?
Yeah. Yes, we are. Thank you for emphasizing that.
Okay.
Okay, let's go at another one. How about let's take a look at number 102. By the way, the earlier ones are pretty doggone easy, so I have higher numbers here. So let's take a look at number 102 and see what that looks like. So number 102 says, find a relationship between x and y. X comma y is equidistant from the 2 points. So you see they gave us those 2 points, comma 5 and 1 comma -8. And they said, find a new point, x comma y, that's equidistant from those 2 points. Well, this we got to pull up something from the past here. Equidistant sounds to me like the distance formula, and it is. So, do you guys remember, how do you set up the distance from xy to 6, 5? Well, the answer is use the distance formula. Let me remind you. I'll put it down here on the bottom. It's basically the Pythagorean theorem, right? Remember that guy? The distance from 6, 5 to xy, or the other way around, well, that would be the square root of x minus 6 squared plus y minus a negative, so y plus 8 squared. That's basically the distance from there to, oh, you know what? I just went, my apologies. My eyes strayed. It's y minus 5. I snuck over to the other point. Okay, now, as a separate thing, this distance from 1, -8 to xy. Again, using the distance formula, that's x minus 1 squared, y plus 8 squared. So, why did I set them equal? Because it said find point xy so that the distance is, so it's equidistant. Wow, how are we going to solve that? Well, we can get rid of the square roots, just square both sides. You know, and then it's just the same problem without the square roots. Went a little too fast. Go too fast and this thing has a hiccup. So now, I mean, now you could hammer it out. You gotta basically hammer this whole thing out. I'll just show you what it looks like. got to square each one of those. And you notice there's an x squared on both sides. That can be subtracted. That's why they're crossed out. And there's a y squared on both sides. They go away. And then you combine the x's and the y's. And, I mean, you wind up with a line. And isn't that, now think in geometry, okay? In geometry, if you've got 2 points, and you want to find all the points equidistant between those, aren't they going to look like this? By the way, in geometry, the answer is the perpendicular bisector of the original line segment. Well, isn't that a straight line? Makes sense that all the points equidistant from those 2 points would be linear line. So it looks long, but I mean, really all it is using the distance formula twice, setting them equal, goodbye square root signs instantly, and then a bit of algebra and solve for y, and no shock. It should be a line. So I guess you could say we just pulled back, even though this wasn't about distance, the distance formula came back to play an important role in this problem.
Hey, Dr. Belo, is it possible to use, when I first saw that, I immediately thought of the midpoint formula, so just out of curiosity, is it possible to use that for a problem like this?
Sure, but how would you use it?
I would think that by using the midpoint formula, you could find the point that was exactly between the 2 points that were given to us, and then we would plug that into our... Right there.
Yep.
Right. And then you would plug that into the whole y equals mx plus b formula. In some way.
Okay, so what are you going to use for the slope then?
Well, the slope would be horizontal, wouldn't it? If it's perpendicular, if it's just a horizontal line, would the slope be 0?
Where did you come up with horizontal?
Well, I was just looking at your picture, and
Here are the 2 points we began with. They're not horizontal or vertical from each other.
Okay.
So I don't think you want to nail that down.
No.
But I like your approach. So you find the midpoint. Okay. What can you do for the slope? You're okay as long as you follow through on that. Can't you just take what? This slope?
Right.
The original problem, and use the negative reciprocal.
Right.
Yeah, you could do that.
Okay, that makes sense.
Yeah, that would maybe take a little less ink and a little more cerebral work. You got to know. Oh, yeah, that's right. Yeah. So you brought back a little bit of your geometry knowledge.
Right.
Point's equidistant. Well, I know one point it's equidistant. That's at the midpoint.
Mm-hmm.
And guess what? You'll get exactly the same result.
Okay.
Yeah, good strategy.
Thanks.
Well, all right, we're at right about at the point of 50 minutes here, guys. Here's the assignment. It's the old every other odd. Yeah, it goes up kind of high this time. There's a bunch of word problems for review there. You know what? I'm going to change that. Instead of 137, let's make that, let's just make it 103. Quite a bit. Okay, so I'm disagreeing. I am changing the assignment to be a smaller number. The other past 103. I don't know if 103 is in every other odd, but don't go past that. Anybody have any other questions before we close this up today? I'm hard to hear now. Okay. Sorry about that. I just got a message from one of the students that they can't hear me now. I don't know what I'm doing differently. Maybe I hit a volume button accidentally. Sorry about that. But the good news is we're done. Thanks, guys. Appreciate your presence.
Thank you.